notes on lesson 5-6, finding distance on the coordinate plane. You can follow along with me in your workbook on page 432. First, we're going to look at how you can use the Pythagorean theorem to find the distance between 2 points on the coordinate plane. Follow along with example 1. We're going to graph the ordered pairs 3, 0 and 7, negative 5, and then find the distance c between the 2 points. We'll round to the nearest tenth. To locate 3, 0 on the coordinate plane, we're going to go 3 units to the right and 0 units up or down. To plot the point 7, negative 5, we would go 7 units to the right and 5 units down. We're going to try to find the distance between these 2 points. Notice, since it goes in a diagonal, we can't just count the squares on the coordinate plane. So, if we draw a vertical line and a horizontal line connecting the two, notice a right triangle is formed. We can use the Pythagorean theorem. First, write down the Pythagorean theorem, a squared plus b squared equals c squared. Then we're going to go ahead and replace a and b with the values from the legs. We're going to let a represent 4 and b equal 5. This is equal to the value c squared. Next, square 4, which is 16, and square 5, which is 25. The sum of the two is 41, so c squared equals 41. Last, to find c, you have to take the square root of both 41 and c squared, which gives us a value of 6.4. Again, we're ignoring the negative value because the distance cannot be negative. So the distance between 0.30 and 7, negative 5 is 6.4 approximately. We rounded this value because the directions told us to round to the nearest tenth. Pause the video and try got it A. Put your answer in your workbook. Next, we're going to go ahead and take a look at the distance formula at the bottom of page 432. The distance formula looks complicated, but really it's not. It's just an extension of the Pythagorean theorem. It says that the distance between any 2 points can be found by taking the difference between the x values on the coordinate plane and squaring it, and taking the difference between the y values and squaring it, and adding the two together. Notice the difference between our x values here to here would be a lot like a. And the difference between our y values would be the other leg, which would be b. So essentially, we're just doing a squared plus b squared. We take the square root to undo the c squared value that we end up with, and that'll give us our distance. So really, it's just an extension of the Pythagorean theorem. Let's look ahead to page 433. This is explained once again at the top of page 443. They take the Pythagorean theorem and they show you that the difference in your x values is really a, the difference in your y values is really b. You're squaring both of them still, and then taking the square root to undo the c squared. So, let's try it. For example number 2, it says on a map, each unit represents 45 miles. West Point, New York is located at 1.5, 2. And Annapolis, Maryland is located at negative 1.5, negative 1.5. We're going to try to locate the approximate distance between West Point and Annapolis. Okay? So, if we use our new formula, the distance formula, x1, y1 would be the ordered pair 1.52, and x2, y2 would be the ordered pair negative 1.5, negative 1.5. First, you're going to use your x values. Your x values will be 1.5 and negative 1.5. So those are going to get plugged in. We have a negative 1.5 minus 1.5. That quantity will get squared later on. Our y values are 2 and negative 1.5. We need to start with the same one that we began with in the x coordinates. So we're going to do negative 1.5 minus 2. Okay. Next, you're going to go ahead and use your order of operations, and we're going to do our exponents before we add. A negative 1.5 minus 1.5 is a negative 3. A negative 1.5 minus 2 is a negative 3.5. Next, we'll go ahead and square those values. A negative 3 squared is 9. A negative 3.5 squared is 12.25. Then we'll add the two together. 9 plus 12.25 is 21.25. Last, we'll take the square root. We get approximately 4.6 for an answer. Again, we're only going to refer to the positive value because distance cannot be negative. If you look along at method 1 on the left-hand side, you can see the same thing was done with the Pythagorean theorem and the same answer was reached. Go ahead and try the got it at the bottom of page 433. Okay, last we're going to do example number 3 at the top of page 434. It says to use the distance formula to find the distance between point X and point Y. Round our answer to the nearest tenth. First, we're going to take our X values, X2 minus X1, so a negative 3 minus 5, and Y2 minus Y1, which is a negative 2 minus a negative 4. First, do your operations inside your parentheses. A negative 3 minus 5 is a negative 8. A negative 2 minus a negative 4 is actually a negative 2 plus 4, which is 2. Next, go ahead and use your exponents. A negative 8 squared is 64. 2 squared is 4. Then add the two together. 64 plus 4 is 68. Last, take the square root of 68, round your answer to the nearest tenth, and we come up with 8.2. So the distance between points X and Y is about 8.2 units on the coordinate plane. For extra practice, go ahead and try the guided practice at the bottom of page 434. Make sure that you put your responses to the Got It problems on Edmodo for this lesson.